Chapter 3, Review Rational Functions. Good luck with your studying. 3.1, Reciprocal of a linear function. Number 1, determine equations for the vertical and horizontal asymptotes of each function. The vertical asymptote occurs when the denominator equals 0. I'm going to set each of these denominators to 0. X minus 2 equals 0, x equals 2. And on this side, x plus 7 equals 0, so x equals negative 7. The horizontal asymptote occurs as we consider x getting very large, or as x goes to infinity. Looking at this, as x gets very, very, very large down here, then the number on top is 1, so x gets really, really large, so f at x actually goes to 0. So as x gets very, very large, f at x goes to 0. So our horizontal asymptote is y equals 0. Similarly over here, as the x plus 7 and the bottom, as the x gets very, very large, it goes towards infinity, then the f at x also goes towards 0. So our horizontal asymptote for this one is also y equals 0. Number 2, we need to determine an equation for each graph. I'm going to do part A on this page. I've noted that the horizontal asymptote for this function is y equals 0. Running along. Running along here is y equals 0. I've noticed that the vertical asymptote is here with the black line is x equals 1. I've also noticed that there is no x-intercept anywhere along here, but there is a y-intercept at negative 2. Now I need to use all of these pieces of information to come up with an equation. The vertical asymptote gives me the bottom, so I know that there's vertical asymptote at x equals 1, so my factor on the bottom is x minus 1. Now I need to figure out what goes on top, right in here. So I do know that this y-intercept negative 2 is the point 0 for x and negative 2 for y. So if I'm going to plug those in here, I get negative 2 equals something over x, which is now, not x, is 0. I'm going to change that to a 0, minus 1. So I still need to figure out what goes in this box at the top. So I want to ask myself, minus 2 equals what number over minus 1? So the number on top must be 2. So then my final equation would be f at x equals 2 over x minus 1. Looking at B, the horizontal asymptote is the line that this is going to go along, which again is y equals 0. And then, looking for the vertical asymptote, this dotted line right here at x equals negative 4. Okay, examining this graph, I also see there's no x-intercept again, so we follow this along and it's not going through the x-axis. I also noticed that this branch goes through, I'm going to say maybe, well this is 1, so I'm going to say maybe a quarter. So let's try and figure out the equation. The vertical asymptote is x equals negative 4, so that means that on the bottom I'll have a factor of x plus 4, which will lead to that asymptote at negative 4, x equals negative 4. The next piece of information I want to use is the y-intercept information. So the y-intercept translates to the point 0 for x and 1/4 for y. So moving down here, I'm going to write 1/4 for the y, or the f at x, equals, and I still have my x plus 4 in the bottom, but now x is 0 plus 4. And then I just need to fill in this box. So again, moving below that, I get 1/4 equals some box over 4. So obviously then, the number that's going to have to go in that box is 1. So my final equation then is f at x equals 1 over x plus 4. Okay, so for 3a, I'm going to find the domain, range, y-intercepts, and asymptotes for this particular function, f of x equals 5 over x minus 3. I'm going to start with the asymptotes. So I know I have a vertical asymptote at x equals 3 because of this denominator. The horizontal asymptote is when I consider x getting very, very large. And as x gets very, very large, y goes to infinity, or y goes to 0. So the horizontal asymptote is y equals 0. The y-intercept for this happens when x equals 0. When x equals 0, I get 5 over 0 minus 3, or minus 5/3. The x-intercept, or sorry, y-intercept is minus 5/3. The domain will include all x values, so x belongs to R, and the only value we're not including is the bottom one, so x not equal to 3. The range would be y belongs to R, and will not include the asymptote as well, so y cannot be 0. To verify our findings, I graphed it. Here we are here. One more question, and then I'm going to call this video complete, and then I'll do the next section. So the vertical asymptote is x equals 4. The horizontal asymptote with this function, as x gets very large, y goes to 0 again, so y equals 0. The y-intercept will set x equal to 0, so we get negative 1 over 0 minus 4 equals 1/4, so the y-intercept should be 1/4. The range, in the range we can't include the asymptote, so it's y is not equal to 0, and y belongs to R. And then the domain, we can't include the asymptote, so x cannot be 4, and x of course belongs to R. So that's that question done. To verify our results, I sketched it on Desmos. Please use Desmos to help you out. Notice that all these things are true. X equals 4 is my asymptote. Up here, x equals 4. My horizontal asymptote is y equals 0. My y-intercept is just above 0 here, so it looks like 1/4. It's pretty good. And that's it. Good luck.